Hi guys, Ashwin here. This is episode 8, part 1 of Sui Deep Dive series, and today we'll be looking into Sui indexers. So Sui actually provides indexer framework where you can utilize utilize that framework. So it is built in Rust. So we use that framework to make sure that you pull data directly from the source. That is like any nodes that they provide, or instead of just recursively pulling data or pulling data from the Sui endpoints that they provide. What we are going to do is we are going to build indexes to pull the data directly from the source, which is going to be any full node, or they have multiple sources to pull data. So we will be building that. So it could be a sequential indexer, or probably a concurrent indexer. But yeah, we will see that in the coming up videos. Yeah. So let's get started with, first of all, what is indexes. So why we need indexes, right? So we can obviously get data from the Sui endpoints, or some other endpoints that something like BlockBerry API, for example. In Sui you can just continuously pull data from the BlockBerry API. But how exactly BlockBerry API works under the hood? Maybe they might be using an indexer. Obviously, why I am telling it might be an indexer, because so when we try to constantly recursively poll the endpoint, that is like call the endpoint of BlockBerry, it is going to make a call to the their instance, that is their server, and that server is going to make sure that it pulls data directly from the source, which is going to be a Sui full node, or it might be a local node that they are running. So they have multiple sources. We'll discuss about it. So it might be the case, right? So why they are using the indexes mainly? So when we think about indexers, or when we think about polling data from the Sui endpoint, there is a latency between how you poll data from the uh, from the endpoint to the indexer, right? Sorry, from to the source, point source. So point source in the sense the full node. There is a latency there, and after you poll the data, then you want to get the data to your client, right? So who is requesting the data to the exact exact API. So there are multiple entities involved, and the latency involved from the, like, duration involved from the fetching data from the source, that is the full node, to the API to the receiver end. So it is quite huge. So what we can do is we can set up our own custom indexers in Sui blockchain, or we can also set up these custom indexers in different blockchains as well. So what exactly Sui provides us is they provide a custom indexer framework where you can use the design your own custom indexes for your own use. Like, you might have a NFT collections where multiple people can buy the NFTs, right? So what you can do is you wanted to save the user details or something like that. It might be getting intense when we discuss about it, when we discuss about custom indexers. Whoever is the purchasing the NFT from the collection, so those data can be stored in your DB, which can be indexed later. So those are the use case that I'm talking about. So let's get into how Sui provides the custom indexer framework, and what is the architecture, and they have different types of you know discussing about indexers. We need different types of indexing methods, probably, not probably. So it is two types actually in Sui indexer framework. One is sequential indexers, and another one is concurrent indexers. So sequentially polling the data checkpoint by checkpoint, or you poll data from partially from a single checkpoint, and then you pull another half of, or another partial polling from another checkpoint. But the watermark should be done. So we will get into this exact architecture in this exact video. So let's talk about the Sui indexer framework and the architecture. So first, to discuss about, we need to see the data sources, right? So the data sources would be yeah. So the data sources, one would be from the remote itself. Remote in the sense, uh, you know to take up an example, it will be given by the Sui itself. It's going to be something like just the checkpoint endpoint, something like 443 port opened, and you call this exact remote endpoint, and you just access the exact checkpoints. We'll discuss what is checkpoint soon. So you access the entire data of each checkpoint, and you start to do different process. We'll come to that. So this is remote, and another one is something like a local store. So what is local store? So we are pulling data from this checkpoint, right? Which is a remote store. So what we can do is we can locally store them, and then you index them later. Or whenever you need. So this is another type of sourcing method, data sourcing method. Another one is going to be RPC endpoints, which we obviously know it's going to be something like for the different environment we have different RPCs, right? DevNet or testnet or mainnet. So based on the checkpoint or the specific environment data that you need to pull, you can call different environments. So these are the three data sources that we need to discuss, and later on what we need to discuss is the exact architecture. So we discussed about the data sources. So yeah, let me just give. So these are the data sources. It can be just the three we discussed. Okay, what this data sources is going to do is this data sources is going to act as a middleman, just making sure that it fetches data from multiple sources, right? 1 2 3 that we discussed. And then what we are going to do is, right now we enter to the core piece of the architecture itself. So now what we are going to do is we are going to build our framework here in the sense the framework that Sui provides. We are going to utilize this and build a Rust server and going to deploy it in an instance, and that instance is going to make calls to these sources to get the data directly. So how it's going to look? First of all, it's going to be the ingestion layer. This exact ingestion layer is going to make sure that it ingests data from this data sources. It's going to be the checkpoints, obviously. So you get the checkpoints directly from the data sources, and then later on we are going to process the data. So we have two components in the ingestion layer. Broadcaster, and another one is going to be which is going to handle the broadcaster, more likely a regulator. Okay, a regulator in the sense where you are going to make sure that I just get this you are making sure that you write a logic to the regulator that broadcaster is the one pulling the data from the data sources, that is we are pulling the checkpoints in. So what we are going to do is we are going to make sure that we use the regulator to have some holding, or it's based on your logic, right? So I just need the first 10 checkpoints for this exact 10-second polling period, or I need the for another second set of polling, you just take 20 checkpoints in, so then we can process in later. So this kind of logic or the regulations you can have using the regulator applied on the broadcaster, so that you can make sure that you control how much checkpoints that you are pulling into the service that we are discussing, that is indexer service that we are discussing. So this is ingestion layer. Next up we have the processing layer. So this exact processing layer has some few bit of components. It's going to be something like this processing layer. What it does is it's going to get the data from the broadcaster and process the data. So you get the checkpoint data and then you're going to process the data. This is going to be something like a hard piece of the architecture itself. So where you're going to have your business logic involved, or say I just need to process only this kind of transaction digest, or only I need to process the sender details or whatever it is. So it's based on your logic, right? So here where your logic relies on, so it's going to be something like indexer framework from Sui provides three different endpoints which we'll be discussing now. One is the process endpoint where you have the core logic, and another one is the commit endpoint. This commit endpoint makes sure that you then process the data, then you send the data to the commit endpoint, then the commit endpoint makes sure that it commits the data to the storage layer. Let's discuss that later, that is the coming up time. Then we have prune. So what is prune here? So prune endpoint makes sure that you prune the data in it's based on your requirement. Say you are polling in 20 checkpoints 10 second per 10 second, and you store it for something like 6 months. After 6 months, what you can do is you can prune the data, right? So using prune endpoint, you can call the exact database or any other custom DB, or the exact framework supports. We'll discuss about which exact DB it supports. It supports every DB. I just want to pinpoint which DB that we are going to use in the next implementation. Okay, so we can make sure that we use the prune endpoint to prune the data once in a while. That's the thing, and this is something like optional. Whether if you want, you can implement, or if you don't need, you need not to implement prune endpoint in your indexer framework. So then what we have is, let me just increase this. Yeah, then we have the storage layer coming up here. So whatever data that it's coming from the commit, that is like you process the data, checkpoint data, and you send it to the commit endpoint, commit handler. Then later on you just commit the data to the storage layer. So it's going to be something like a custom DB that you can design, mostly based on whatever schema that you want, right? So for example, I just need something like it's based upon you. You can use also MongoDB, NoSQL as well. Sorry, you can use MongoDB as well. It's totally up to you, right? So this is all about the architecture that we want to understand, to basically understand about the Sui indexer framework. So next up, what we have is to discuss about what exactly is concurrency, and then sequential. So when we discuss about Sui indexer framework, so when we discuss about sequential, first of all we'll discuss about what is checkpoints first of all. Okay, so let's discuss about checkpoints now. So what is checkpoints? So in the Sui consensus, or consensus mechanism, or the Sui's transaction processing method, if we know about that, checkpoints are nothing but very much similar to what we are doing in the segregating of transactions and constructing a block in EVM. It is very much similar to checkpoints, but quite a bit different over here. But we'll just go overview of what is checkpoints here, because I don't want to have a comparison now with checkpoints and what is block here, because there is quite a bit difference here. But we need to understand from the beginning of how the how we process the owned objects and shared objects to the consensus, and how we process the owned objects directly to a faster execution path. Everything we need to discuss about. We need to discuss of how in each criteria the checkpoints works, right? So to basically understand, or to just understand in an overview fashion of checkpoints, we can just assume that this checkpoint is more like a block, and it's going to contain multiple transactions in it, transaction digest and its specific details, its specific details. Okay, so this is how it's going to look. Maybe in the sense, just I am for better understanding, I am giving you an overview now. So this is how checkpoint is going to look, and now what we are going to do is we are going to discuss how sequential and concurrent indexes works now. So let's say I have a sequential indexer implemented. Let's say I have a sequential indexer implemented. This exact sequential indexer is going to make sure that it's going to pull the data from from the data sources, and it's going to the ingestion layer. Then the ingestion layer is going to give to the processing layer, right? So it's going to give checkpoint by checkpoint. So let's say here also another topic comes in, or another just buzzword comes in. It's watermarking system. So what happens is, first I'll give overview now. So what I'm going to do is I'm going to pull the data from the data source, and checkpoint by checkpoint. If I get the first checkpoint, a complete data ingested into the ingestion layer, and then I'm going to make sure I process it. Then after processing the complete checkpoint, I'm going to commit that to the storage layer, right? So when I do that, I just mark it. I'm going to say in my DB, custom DB, watermarker something like the first checkpoint 1 is true. It is done, okay? If next up another sequence, like it's going sequentially, right? So when 1 is completed, then only we are going to pull another checkpoint, not something like concurrency, concurrent indexer. So we are discussing about sequential indexer. So when we talk about I'll just write them. So let's say this is C1, C2, C3, and I just got the data C1. This is ingestion layer, and I'm going to process it, and after processing I'm going to commit it. Okay, here in the commit I'm going to make sure that I also I mark the commit is going to make sure that watermark of C1 is true. The whole checkpoint itself is committed and processed also is done. So if the processing fails for exact checkpoint, then the watermark will become false, so that we can have a fallback mechanism where since the watermark marked it as false, we can make sure that we have a fallback mechanism to say that process the exact checkpoint again, and after the entirety is processed, we are going to make sure that we are going to commit it to the storage layer, and then later we are going to come again to C2. Okay, so later this is how the watermarking system works, and the sequential indexer works. Now let's discuss about how concurrent indexer works, right? So when we discuss about concurrent indexers, it can be something like let's say I'll just get the laser. So in this concurrent indexers, I am going to make sure that I am going to get the C1 to the ingestion layer, and process just a bit. Okay, one thread is going to be we are going to obviously have the Tokyo runtime. So it's going to make sure that it has a thread pool and multiple threads handling multiple checkpoints, right? So in our case, we just assume that it's going to be something like a thread imported from standard library just for this purpose. But obviously in the Rust indexer, or sorry, in the Sui indexer, we are going to have the Tokyo runtime. So when we talk about Tokyo runtime, or for now, for the basic understanding, we'll go with just the standard thread concept, like spawning one single thread for each checkpoints. Okay, but in Tokyo runtime, we have work stealing mechanism. We'll discuss about that in the upcoming implementation. So we are going to get the C1, and for this exact C1, we are going to spawn a thread. Let's say C1. Okay, I have some. So for C1, I spawn thread 1, and this exact thread 1 is going to do the work partially, and C2 thread 2 something like partially. I guess probably this exact partial processing of the checkpoints is basically because of multiple threads accessing multiple checkpoints at once, or it might be something like because of the work stealing mechanism in the Tokyo runtime. You can obviously lock this thread for the exact checkpoint, but yeah, I'm just assuming, because we are going to implement it in the next part. So assuming, in the sense, what I'm coming to tell is this partial processing of checkpoint basically happens because of multiple threads working on multiple checkpoints. So it shouldn't be something like data racing, right? So for instance, thread 1 is making a process on C1, and thread 2 also tries to make some process on C1. Then a data race occurs. So what the exact process would be is, thread 1 process the data C1, and for a particular period, for say 50 milliseconds, then partially it processes the data and then commits it. So here, when we talk about the concurrent indexers, it's just the overview, because there are multiple components involved in concurrent indexers to make sure that this exact, it's a bit very complex when we talk about sequential indexer and concurrent indexer. So I'm just giving an overview, because we will deeply involve concurrent indexers in the with comparison to the Tokyo runtime as well, why it is implemented in this fashion, because it is obviously implemented using Axum framework. So I'm just giving you an overview of concurrent indexes in this video. Yeah, let's continue this exact implementation of sequential indexer or concurrent indexer in the next part, and yeah, see you. Thank you.